In this video, we'll be reviewing how does a compiler view code. I'll show you a quick C to disassembly and explain the disassembly with the comparison to C in Compiler Explorer. We'll be reviewing C to disassembly, indirect addressing, viewing of structs in disassembly, reversing methodology shifts, identifying loops in assembly, identifying .bss variables, calling conventions, function prologue and epilogue, stack frames, identifying array indexing. All of these things is just a quick starter to learning how to reverse engineer efficiently. Enjoy the video. The C on the left and read the disassembly on the right. All three of these global variables are here will be stored in the BSS section. They are global uninitialized variables, so they would be in the BSS section. It's important to note that this would be in the BSS section too. You know, it has a size, but it has no contents. We have this first label here, so we have dead beef and array right here. We have these variables. We have this label here, which is the little encryption function. It'll start with some function prologue and some function epilogue at the end. EDI, ESI, and EDX will contain A, B, and C respectively, and they'll be controlled from RBP -4, RBP -8, and RBP -12 at their respective dword pointers. EAX will contain A, and then will get multiplied by B. It'll then, the result of which will then get XORed by C, then the function epilogue. We have this loop function here, or label. Function prologue right here. 16 bytes of data stored for variables on the stack in this stack frame. It'll move 0 into RBP -4, which will contain the counter variable. So this is the initial setup right here. And then it'll jump to L4, which is the actual looping functionality. RBP -4, which is the counter, will get stored at EAX. It'll then compare to 600, which is the size of the array. If the counter is greater than the size of the array, it'll move on to the rest of the loop. If not, it'll not believe in ret, which is to restore the original control flow. So we'll look at L5 here. It'll move dead beef into EDX, and it'll then RBP -4, which is the counter, will be moved into EAX. It'll CDQE, which is to 64-bit sign extend the EAX register. It'll move the array at RAX ×4, which is the counter. So the array is getting indexed, and it'll be at 0 plus RAX ×4. The ×4 is for the counter, which is the index. It'll move the counter into EAX. It'll move ECX, which had the array and index value. It'll be moved into ESI. EAX will then be moved into EDI, and then it'll call the little encryption function. Moving on. Counter will be moved into EDX. Sorry, I just lost my train of thought. And then move SX, RDX, EDX. EDX being stored into RDX. Move SX is probably just like CDQE sign extending that register. Let me just check.
Oh, brother, this guy stinks!
Change the byte locator at the copies the contents from the source operand, destination, sign extends. Yep. So it'll just sign extend EDX into RDX. So moving on, we're putting EAX into that. Well, the sum of everything will be moved into the value at that index of array. And then it'll increment the counter. Moving on to the main function, main label, we'll have this string stored in .data for the printf function to use later. Some function prologue here, storing 16 bytes of stack space for variables. In this case, the struct. It'll move EAX 0, and then it'll call the loop. So this is where the loop is getting called. Then it's going to initialize the struct. So the actual initialization isn't actually shown here, right? Like this right here isn't shown. But what is shown is when it's getting assigned. That's probably just because like the compiler doesn't care until it's assigned or whatever, I don't know. So at RBP minus 16, which is i.pwnpwn, it'll store 1337. Pwnin will store 0 at RBP minus 12. At Pwna, it'll store 1337 at RBP minus 8, all of those respected dword pointers. Okay, moving on. It'll move EDX, ECX, and EAX, the Pwna, Pwnin, and Pwnpwn variables. It'll then move ECX into ESI and move EAX into EDI to call lull encryption. I guess this would be a good time to talk about indirect addressing and calling conventions. So the standard Linux calling convention, or the Linux ABI, follows EDI, ESI, EDX, and ECX, or ECX, EDX, I forget. It'll then go R8 to R10, and then whatever after that will be pushed on the stack, I believe. Please do correct me if I'm wrong on that. Okay, moving on. It'll then move the result into RBP minus 4, being the value variable. It'll move RBP minus 8, which is the Pwna variable, into ESI. Pwnin will be moved into ECX. RBP minus 16, which is Pwnpwn, will be moved into EDX. And RBP minus 4, which is the value, will be moved into EAX. R8 will contain ESI, which is the variable, not the variable, sorry, the field, what's it called? Sorry, the field PONA. EAX will then go into ESI. EAX contains EAX contains the field PON, and then it'll move the string from that label LC0 into EDI, and then move 0 into EAX, because it doesn't have to work with any floating point numbers for printf. And then so it'll call printf, set up all that good stuff. Value, pon, ponin, pona will all be called. And then it'll move 0 into EAX, leave in ret, which is all the function epilogue, sorry.